Hi everyone. This is example 1 from the lesson 1-2 on random samples. And actually it's example 1, but it's the only example here. And there are several parts as you can see, but we're going to kind of just use this time to go through this example so you can see all of those words we just talked about in action. Okay? So if you haven't had a chance to read this example yet, go ahead and read it. I'm going to kind of summarize it for you. Basically, a company is trying to decide if they want to purchase generic computer disks as opposed to name brand ones. Okay, and this is a decision that companies make all the time, even if the idea of computer diskettes are sort of obsolete. But you could throw any other word in there, and this same situation still arises. So this company is going to purchase a lot of these things. They're going to purchase 100,000 of them from the manufacturer. And they're aware that sometimes these things are defective, right? It's just something that happens. But they want to make sure they're not getting a lot of defective ones, right? So they will commit to purchasing all 100,000 if no more than 1% of the diskettes are defective, okay? So realistically, they're not going to take the time before they commit to purchasing to test all 100,000 of them. So they're going to take 800 of them and test those 800 for defects, okay? And then those results will be used to estimate the overall percentage of defective diskettes. So going back to some of the words you learned in the first lesson in this chapter, the population and the sample. Remember, the population is the large group and the sample is the smaller group that you're actually going to test. So the population would be the 100,000 diskettes. The sample would be the 800 that we're actually going to take and test. Okay? The parameter and the statistic. And notice these are stacked under the words that they go with. So the statistic, starting here, because these are the ones we're actually testing, this would be the percent of the 800 diskettes that are actually defective. So these are the ones we're actually testing, so we can come down to a firm number here. Okay. The parameter would then be me taking that statistic and generalizing it to the entire population. So the parameter would be something like the percentage of the 100,000 diskettes that we project to be defective. I'm going to run out of space here. Sorry about that. I'm trying to write fast for you. So the statistic is an actual number, right? We actually tested them. We know how many there are. The parameter is what we get when we take that statistic and project it out to the entire population. Okay, so let's suppose we were going to do this with a simple random sample. And what this is referring to is how are we going to choose the 800 diskettes, okay? So a simple random sample would be to somehow number the diskettes. And maybe they're already numbered. Maybe they have a serial number or something on them. Okay. And then use a random number generator. So anytime I ask you about a simple random sample, this is going to come into play somewhere. Okay, a random number generator or a random sample generator of some kind, whether it be the one on your calculator, whether it be drawing numbers from a hat. Maybe they're going to put all 100,000 serial numbers into a giant hat, and they're going to choose numbers from there 800 times. Okay, but in some way there has to be a random number generator involved. Okay, so a systematic sample, okay, would be something like pull out every struggling on the math here, but every something diskette, Okay, so every fifth diskette or every 12th diskette, until you have 800. Oh gosh, have 800. Okay, so maybe it's every 100th diskette until you reach 800 total. Okay, we'd have to do some division here to figure out how many 800s go into that 100,000. So that's where I was kind of jumping over that. I don't care so much about you taking the time to calculate that number, as long as you know that a systematic sample is going through the boxes and counting through 100 of them and then saying, oh, I'm going to pull that one, and then counting through another 100 and then saying, I'm going to pull that one. Okay. A cluster sample in this scenario would probably have something to do with how they're packaged. Okay. So randomly choose boxes. I'm assuming they'd be boxed up. Let's suppose they're boxed by 100. Okay. So we would choose 8 boxes at random. And when I say randomly choose, we're probably going to want to go back to our random number generator. Okay. And test all diskettes in the chosen boxes. Okay, that would be a way to do a cluster sample here. Okay, this is not a situation that I think a stratified sample really works for. A convenient sample would be something like just walking in and pulling the first 800 diskettes off the shelf. Okay, not the greatest idea if you're trying to see if less than 1% of them are defective. Okay. Okay. What are my next questions here? I don't remember. So once we choose the sample, what variable are we studying? What are we trying to find out about these diskettes? We're trying to find out whether or not they're effective. So I'm just going to say effectiveness. Okay. And then how would we make an inference on the population based on the sample? Well, I would say, and I'm not going to waste your time writing this entire sentence out. I'll write down the important stuff. But what we're really getting at here is that process we talked about back here where we said that we're going to find the statistic and then we're going to project to the parameter. That's what this question is asking about, is how are we going to make that projection? And basically, if less than 1% of the sample is defective, then less than 1% of the population is likely to be defective. So I would say if there are less than 8 defective out of 800, because 8 is 1% of 800, okay, then fewer than 1% of all of them are defective. So if we test those 800 and there are fewer than 8 that are defective, then chances are we can say it'll be less than 1% across the board. If more than 8 of them are defective, that's more than 1%, and so there's a high likelihood that more than 1% of them would be defective across the board. Now, this is not a guarantee, right? This is an inference, meaning we're making a projection, we're making a prediction about what's going to happen. We aren't guaranteed to know that that's going to be true, okay? So I kind of jumped over these at the beginning because we were going to kind of talk through them throughout this process. But this is what it means to do an inferential study. This is the process we go through. We determine a population. So in this case, our population was these computer diskettes that haven't been used since like the early 2000s. Choose an appropriate sampling method. So we kind of talk through some of our options. There are definitely like ones that are better than others, even looking at this list that we made. Ones that would be better ways of choosing your sample. So we would have to put some thought into what's the most appropriate way. We'd have to actually do the testing, right? We'd test all 800 that we chose, okay? Analyze the pertinent information really just means look at the numbers, okay? When you tested all 800, how many of them came back as being defective? Then we can use that sample to make the inference, and that's sort of what we talked about here, okay? And then you always want to take a minute and just kind of reflect on how reliable this was. So if I just grabbed the first 3 boxes off the shelf and said, okay, I've got my 800 and I tested them, was that really an accurate representation of the entire population? Okay. Or if I let the company send me the 800, they're trying to sell these discs to me. If I let them choose the 800 that they're going to send me, then I'm pretty sure that's not truly representative of the entire population, right? So just think about those things before you come to your conclusion. Okay, that's all this is talking about. I wouldn't put a whole lot of time into like memorizing this step by step, but just understand the process that we just went through. Okay, that should do it for this week. Let me know if you have questions. A lot of this is just going to be vocabulary based and getting you thinking about how to do all those different random samples. All right, have a great night.